now the second type of formula is something called compounded continuously. What that means is instead of paying you once a year or once a month or whatever, they just keep paying you, just keep calculating it. So here's the formula for it. You'll see the same letters in it. A equals P still being the principal. R is still the rate as a decimal. And then T is going to be the time again. The different guy here is E. E is a variable like pi. It's not actually going to have a value. It's just a variable. So no value here. It's just a button on the calculator, basically. So reading through the problem, again, there's some keywords you look for. Compounded, right? And then this one is special because the other word you look for is continuously. That's when you know to use this formula right here. Continuously. You're going to say that to yourself again and again. Continuously is the key word here. Compounded lets you know you're using the formula, but continuously lets you know you're using the formula with E. We call it PERT, right? P-E-R-T, PERT. All right, let's pull these numbers. Total amount of money after 2 years, okay, T equals 2. $100 is invested, that's our P. Interest rate of 5.5%. Can you hear my dog? He's clickety-clacking all over the floor, walking back and forth. Distracting. Okay, percent to decimal, we go 2 spots to the left. We had to add a 0. So R, the decimal, is 0.055. And now we can plug in. So A, capital A, equals P, 100. E, just leave it as the letter E. And then up in the power is R, 0.055, times, I'm going to put parentheses there to put my T in. So that's my T, that was my R, and that was P. Okay, now plug this into the calculator. Your calculator has an E button. It is on the calculator, this is second. That's the blue button at the top. And then if you hit the LN button, it's like the third one up from the bottom, I think. I'll show you on the calculator. If you hit that, it will put in the E for it. But if you actually go to Desmos, which is where I'd recommend, they have an app. You can do it on your phone, really easy. You can do it from your computer. You're going to just type it in as a regular E. So you would say 100, and then on your keyboard hit the letter E, and it automatically knows that that's that value E. And then the caret button, the raise it to a power button, is Shift 6. And then you would say 0.055 times, oops, look, it dropped me down to the other one. That means I need parentheses around this guy, not 9, parentheses, so that I can tell it to multiply inside. There we go. So 111.63 should be my number. So A equals 111.63. So I would recommend Desmos for these ones just because there's so much going on and it's easier if you don't have to search for stuff. If you were going to plug this into the calculator though, you would do 100, and then you're going to do E, which again is to hit the blue button, and then hit the LM button, and then you'll hit the caret. Don't forget parentheses so that we know to multiply those numbers together, both up in the power. And you should get the same thing. All right, look at these two examples. It says, which of the given interest rates and compounding periods, so we found that compounding word to let us know we're using these formulas, would provide the better investment. So we've got 9.25, that's our R, percent, changing that to a decimal. 0.0925, and then it's compounded daily. And then you ask yourself, how many days are there in a year? 365. That's going to be our N. Now, it doesn't give us a P or a T. That's because you can pick any one you want. I'm going to keep it easy and just do P of 100. And we're just going to do T of, let's say, 5 years. And then down here for this one, for 9, it says compounded again, so we know that we're using a specific formula. But this time it says compounded continuously. So it's going to be a different formula, compounded and continuously. So this one, I still haven't, or sorry, whoops, not a highlighter. I got a pen in red. So for this guy, I've got a new R, 9%, or if I move the decimal, that's 0.09. And then compounded continuously means I have the formula with the E in it. But besides the R, I would need the T. Again, we're using the same T for both problems. We're just comparing based off of the information given. And the same P. Those are going to be the same for both problems. We decided up here it was compounded regular, so 1 plus R n to the n times T. All right, I'm going to plug it in here. 100, 1 plus 0.095 over n, which was 365. And then up in the power is 365 times, we chose 5. So in the calculator, you would do 100 parentheses 1 plus 0.095, divide symbol, 365, parentheses, the power button, new parentheses, so that you can do 365 times 5 in there. To about, okay, I got 156.83. And then for this one, we've got 100 e to the 0.09 times 5. Again, in the calculator or on decimals, 100, type the E, that's the second button, and then the LM button. And then the caret to show it's in the power, parentheses, 0.09 multiplied by 5, enter, which is about 158.79. So it looks like continuously would pay out more money, but it's not a lot of money, right? It's less than $2. So it's not necessarily how many times you're compounding it. It does have an effect on it, but these interest rates are going to change stuff too.
We don't seem to have your retina scan, your fingerprint, or your colonic map on file.
Yeah, well, I did open the account over 1,000 years ago. What about my ATM card?
Do you still remember your PIN number?
Sure. It's the price of a cheese pizza and a large soda back where I used to work. Panucci's Pizza.
Okay, you had a balance of 93 cents.
All right.
And at an average of 2.25% interest over a period of 1,000 years, that comes to $.
Okay, now you had to listen kind of close to it, but she mentions a bunch of numbers. Right? She says that he started out with 93 cents. That was his balance way back when. And then really quickly she says 2.25%. And then she also says annually. And that word was hard to catch. But she says annually, which means N is going to be 1. And then he mentioned that it had been in there over 1,000 years. So those will be the values that we're going to use. Oh, it's going to try and set it off. Okay, first let's turn our R into a decimal, so 2 places to the left and add a 0, 0.0225. And then it was, my computer's wigging out a little bit, isn't it? And then it's going to be this formula, the regular compounded one, but with the n equals 1. Okay, plugging in our values, 93 cents. 1 plus R was 0.0225 over n, which is 1. It's not necessary to write that in there, but we'll just write it in so we can make sure we've got the whole formula. And then up in the power is n times t, which is 1,000. So what you're basically plugging into the calculator is 0.93 parentheses 1 plus 0.0225, because the 1 in the denominator doesn't matter. And then upper in the power is 1,000. Now I plugged that into Desmos, and I got this. 4.28 blah, 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 times 10 to the 9. What that actually is I'm going to round it to 4.3, times 10 to that 9 power. That's called scientific notation. I don't know if you guys remembered or not. But what that says is, okay, now take that decimal and move it to the right 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Whoa. Where did that come from? So that is, I'm going to put my commas in so that we can see exactly the amount.
And at an average of 2.25% interest over a period of 1,000 years, that comes to $4.3 billion.